Hi, if you join us, this is year 11 Maths Advanced Trigonometry, one of the harder proofs. Here, the easiest way is, I'm going to say the left-hand side is either cos theta tan theta minus 1 on sine theta plus cos theta. Because they have tan theta plus 1 on the right-hand side, on the bottom, you want to introduce that by multiplying both sides by tan theta plus 1, both top and bottom. Try that first. And then what you get then is the top is the difference of two squares, which is tan squared theta minus 1. And the bottom is just sine theta plus cos theta. And then on the bottom here is tan theta plus 1. But then on the right-hand side, you also have sine theta minus cos theta on the top. So you might want to multiply both sides by that, both top and bottom. Because whatever you multiply by top, you're going to multiply by bottom. That means you multiply by 1. That's not changing anything. On the bottom here, these two becomes difference of two squares. The other two before was the difference of two squares. You get cos theta tan squared theta minus 1 on the top times by sine theta minus cos theta. And on the bottom, you have sine squared theta minus cos squared theta. And of course, you're still left with tan theta plus 1. All right. What is then tan squared theta minus 1? Well, you know, if you recall back that 1 plus tan squared theta is sec squared theta. So if you then take away your effectively what you want is you want that on that. So this whole thing here should equal to basically 1. Yeah, and that's right. That's what you're trying to get at. So to the other way is then, of course, when you multiply this out here, I'm missing something else, by the way. I'm missing a cos theta on the bottom here, of course. Yeah. So you're still missing a cos theta on the bottom here on the right-hand side. So what you want to do is, of course, try that as well. So if you multiply by cos theta and cos theta on top as well. I haven't tried that yet. Now let me try that. So if you multiply by cos theta and then cos theta here, then you have a cos theta there on the bottom too. So that cos theta and cos theta becomes cos squared. And then that's sine squared theta minus cos squared theta. I write out here. All right, so then you have sine theta minus cos theta left, tan theta plus 1 times cos theta. Yeah, so this is what you want, right? All these should equal to 1. But we'll see whether it does equal to 1 or not. Yeah? So you know that tan squared is really sine squared on cos squared. So that's sine squared on cos squared minus 1. And that's sine squared minus cos squared. And the sine minus the cos is still there. And the tan plus 1 is still there. And the cos is still there. So abbreviated. So when you multiply it in, cos squared times cos squared cancels out. And you end up with sine squared. Cos squared multiplied in, you get cos squared. And then you have... basically, that's on that, which is 1, and you're left with sine theta minus cos theta on tan theta plus 1 times cos theta. So this is 1. So that means you just end up with sine theta minus cos theta on tan theta plus 1 times cos theta. That is one way of doing that. Of course, there's many ways of doing it, but that's one way of doing that. And the right-hand side sort of tells you what to do, basically. And that's that question. You can do this question in another way by doing it like this. So the original question is left-hand side equals cos theta tan theta minus 1 on sine theta plus cos theta. You could go, all right, that equals to sine theta on cos theta minus 1 all over sine theta plus cos theta. You multiply it in, you get sine theta minus cos theta on sine theta plus cos theta. And you're going to do the right-hand side. All right, that's your right-hand side. You want a sine theta minus cos theta on top. There you have it. And the bottom is you want tan theta plus 1 times cos theta. Well, this is where the ABC comes into handy. Well, there's your sine theta minus cos theta. If you divide this by cos theta on cos theta, you effectively divide it by 1. Yeah. So basically you have sine theta minus cos theta all over sine theta plus cos theta divided by cos theta, and you have a cos theta over here. So you split this up. There's your ABC. And then sine theta on cos theta is tan theta. So the sine theta minus cos theta. And cos theta on cos theta is 1. So there's your tan theta plus 1. And that's your cos theta. And that's basically the right-hand side also. So that's another way of doing that. Yeah. If you consider it that way too. And there's more than one way to prove any trick, by the way. And that's where I stop.